Imagine a computer so powerful that it can solve problems in seconds that would take today's best supercomputers hundreds of years. That's the promise of quantum computing. It's not just a faster version of classical computers, it's an entirely different way of computing. But how does it work? And why is everyone, from Google to Microsoft to the US government, racing to develop the most powerful quantum machine? Today, we're diving deep into the mind-bending world of quantum computing, how it works, and why it might change everything, from cybersecurity to artificial intelligence, and even the search for extraterrestrial life. Let's start with the basics. The difference between classical and quantum computing. To understand quantum computing, we first need to understand how classical computers work. Your laptop, smartphone, and even the most advanced supercomputers all rely on a system of bits, the fundamental units of data. A bit is either a 0 or a 1, representing an electrical signal being off or on. Every calculation, every process, every app you use is built from billions of these bits working together. Quantum computers, on the other hand, operate on qubits, short for quantum bits. Qubits are a different beast entirely. They don't just exist as zeros or ones, they can exist in both states simultaneously, thanks to a strange quantum property called superposition. But that's not all. Qubits can also be entangled, meaning the state of one qubit is directly linked to another, no matter how far apart they are. This allows quantum computers to perform incredibly complex calculations at an unimaginable speed. Let's break these quantum properties down one by one. Superposition, being in two places at once. In the classical world, if you flip a coin, it can land on heads or tails. In the quantum world, imagine that coin spinning in the air and being both heads and tails at the same time. That's superposition. A classical bit can be a 0 or a 1, but a qubit in superposition can be both at once. This means that when you perform a calculation, a quantum computer can consider multiple possibilities simultaneously rather than one at a time. For example, let's say you're trying to solve a maze. A classical computer would try each path one by one until it finds the exit. A quantum computer, using superposition, could explore all possible paths at the same time, massively speeding up the process. That alone is mind-blowing. But when you combine it with entanglement, things get even crazier. Entanglement, the mysterious link between particles. Albert Einstein called entanglement spooky action at a distance because it defies common sense. If two qubits are entangled, changing the state of one will instantly affect the other, even if they're light years apart. This means that quantum computers can share information across qubits instantly, making their calculations far more powerful than anything a classical computer could achieve. It's like having millions of chess players solving different parts of a problem simultaneously and then sharing their answers instantly. This property is what allows quantum computers to scale exponentially in power. Quantum gates, how computation happens. In classical computing, logic gates like AND, OR, and NOT perform basic operations on bits. Quantum computers use quantum gates, but they work in a completely different way. Quantum gates manipulate qubits using quantum mechanics, creating complex interference patterns that allow for powerful calculations. The most famous quantum gate is the Hadamard gate, which puts a qubit into superposition, enabling quantum algorithms to run in parallel. Another critical gate is the CNRT, controlled NOT gate, which creates entanglement between qubits, ensuring that their states remain linked. Together, these gates allow quantum computers to perform calculations that would take classical computers millions of years. Quantum algorithms, breaking the impossible. So what can quantum computers actually do? They're already showing potential in several key areas. Breaking encryption. One of the biggest concerns is that quantum computers could crack modern encryption, making current cybersecurity obsolete. Algorithms like Shor's algorithm can factor large numbers exponentially faster than any classical computer, which threatens everything from banking security to private messages. Drug discovery. Quantum computers can simulate molecular structures with incredible precision, allowing pharmaceutical companies to develop new drugs and materials faster. AI and machine learning. Quantum algorithms can accelerate machine learning, making AI systems smarter and more efficient. Optimization problems. From logistics to finance, quantum computers can solve complex optimization problems, like finding the fastest delivery route across an entire city in an instant. But while the potential is enormous, there are still massive challenges to overcome. The challenges of quantum computing. Despite all the excitement, quantum computers are still in their infancy. The biggest challenges are error rates. Qubits are incredibly delicate and prone to errors. Even the slightest interference from the environment can cause them to lose their quantum state. a problem known as decoherence. Cooling requirements. Most quantum computers must be kept at temperatures close to absolute zero, 273 degrees, because heat causes qubits to lose their quantum properties. Scaling up. The largest quantum computers today have only a few hundred qubits, while experts estimate we need millions to achieve truly revolutionary breakthroughs. This is why companies like Google, IBM, and Microsoft are investing billions into solving these problems. The future of quantum computing. Quantum computing is still in the early stages, but progress is accelerating. Microsoft recently announced the Majorana 1 quantum computing chip, a step toward more stable and scalable quantum systems. Meanwhile, Google claims to have achieved quantum supremacy, where a quantum computer outperforms the best classical supercomputer in a specific task. The future could bring quantum internet, completely secure, unhackable communication networks, advanced AI models that can learn and improve at an unprecedented rate, material science breakthroughs, new materials for everything from superconductors to batteries. We are at the dawn of a new era, and while it might take a few more years, or even decades, before quantum computers revolutionize our world, one thing is certain: the quantum revolution is coming. Quantum computing is one of the most exciting frontiers in science today. It defies our classical understanding of reality, operates on mind-bending principles like superposition and entanglement, and has the potential to reshape technology as we know it. But there's still a long way to go before these machines become practical and accessible. So the next time you hear about quantum computers in the news, you'll know exactly what's at stake. Would you trust a quantum computer to handle your data? Let me know in the comments. And if you found this video mind-blowing, hit that like button and subscribe for more deep dives into the future of technology.